What's up, guys? Let's take a look at another CodeWars exercise. This one's called credit card mask. Whenever you're on a website and they say, do you want to use this credit card again? Or it could be other things like, is this you? And it's got the social security number. They don't show the whole thing. They show just enough at the end to help you identify, but not enough for a snooper to get all your info. So what they ask for is 4 digits at the end and everything else turned into hashtags. If there aren't 4 digits at the end, we do as much as we can. And if there's nothing, we do an empty string, which is at least consistent. It's always a string. We don't have to return none or false or whatever. So let's give it a shot. And it turns out that this is a lot easier than you might think, because you could start by saying, all right, if it's too short, then we return the whole thing. They give us the number in the form of a string, so we don't have to do any conversion. And then at the end, you might be like, if. It turns out we're not going to need those. Let me show you what I mean. So I'm going to break it up into 2 parts. I'm going to say hashes is something, and numbers is something, and then we put them together. This is not really necessary, but it's nice, and it follows the pattern that I've done in the previous couple exercises, which means I'm on a roll. I'm not starting from scratch each time and looking at a blank page. So the hashes, how do we get that? Well, it's different every time. Okay, standard credit card is 16 numbers, I think, but this is not always going to give us 16, so we can't just say 12 hashes and 4 numbers. It might be no hashes, or it might be a lot more. It depends. So you could say, all right, I'm going to go hash, and we would add it +1 at a time, like with a loop, but when you're doing a lot of pluses, that's the same as 1 multiplication. In many programming languages, you can't multiply strings, but in Python, that is perfectly fine. It's what they call operator overloading. So the times, the star, works with integers, it works with floats, it works with strings. It might work with other things too if we write the code for it. And we're going to go len of cc minus 4. And then I have to put that in parentheses. So that's great. And it turns out that you might worry, hey, if it's 16 and we go down to 12, sure. But if it's 2 and we go to -2, is that going to give us a problem? Well, it turns out that no, the people who wrote the Python multiply magic method for the string, they expect that, they're going to take care of us, it's great. Now what about the numbers? We need the last 4 of the string, so we can go index. If you want a random number, you can say like 1 and it gives you 1, but if you want more, if you want a big chunk, that's called a slice, and you can do it with the colon. So if I wanted 1 to 5, I could go 1 to 5, right? Or if I want 1 to the end, I can say 1 colon and it goes all the way to the end. Now if I want the last 4, I can say -4 colon, so it starts at the 4th to last and it goes to the end. You might worry, hey, what if there aren't 4? Is it going to give me an error? Is it going to give me bad info that's from the previous byte that could be whatever? Nope, Python is nice, it's convenient. It might make us lazy, it might make us spoiled because we don't have to worry about all those things. But if I start testing, hey, I got it. And it turns out we don't even need this top line because it handles it. If we have a shorty, the length can be negative and it's just going to give us an empty string. And the length can be not enough, and it'll give us as much as we can. So if you say, like, give me the last 4, and there are only 2, well, it'll just give us 2. Now, let's look at the solutions from other people and see if they've found anything different or surprising. This first one is the same thing we did, just a single line. You don't really need to give it a name. You don't really need to have intermediate steps if it's really short and if it's readable. Like, I wouldn't want to do one line that was stretching 100 characters across the screen. But this one, I can see it's hash times something, and then we get a slice. And I could understand that without a whole bunch of names. So that one's great. I gave them an upvote the last time I had this open. This next one is pretty much the same thing. They just spread it out a little bit. Since they used the len twice, they gave it a name, L, because no need to make the computer call that function twice. We'll call it once, hang on, and then use it twice. And they did the thing that we considered at the beginning to check if it's too short. Turns out that's not necessary, but it's still nice for the human looking at this. They might consider, oh yeah, they might be short, and it might help them in the big picture. So I don't mind this line, even though it's not needed. It's not bad, right? And then they do pretty much the same thing we did. If we scroll down, we'll see a few other ones. We have a dot format, which can do a lot of things, but one of the things it can do is what they call fill, which is like padding the string, adding a little bit to the left or right to bulk it up to a certain size. That happens a lot with text. You want it to be shifted over to the right or to the left, and that's great. I've never used the dot format method because I do F strings with a similar result, but it has a lot of useful things. This one has a loop, and in the loop they just fill in each spot one at a time. No problem. It's not that many lines. Great. This one is almost the same as ours, but instead of doing len -4, they do len of the ending or len of up to the ending, and it's got the same result. And again, it doesn't have an issue. If you say like go up to the fourth to last, but there isn't a fourth to last, that's fine. It'll just give you an empty slice or a 0 when you take the len of it, and that's no problem. These will continue to show mostly the same stuff with a new one every once in a while. The .rjust stands for right justify. If you have text and you want to shift it over to the right to make it a straight line on the right margin, you know, there's a method for that. I've never used it, but it's pretty clearly self-explanatory. You tell it how far we're going and what to fill in. So you got to remember that computers, even though they started out with a little bit of math to crack the Nazi codes and calculate artillery trajectories, most media technology that humans have made, printing press, newspapers, websites, most of our technology involves text. And we have a ton of text concepts over the last several hundred years about how it's arranged, how it looks, are we shifting it, uppercasing it, sizing it, justifying it, whatever. And the Python string class builds in a lot of those already. It's great. So I'll end it here because this is a simple one, but if you did scroll down further, you'd see a little more variety and a little more different taste of the people who wanted to set it up a certain way, even though they all work. Thanks.